Okay guys, so I am going to continue with this. So for number 6, it says the volume of this room is roughly 8,500 liters. So there we have a volume. Using the temperature, for room temperature, 25 degrees, we have a temperature. And pressure, remember when we have 760 mmHg, that is equal to 1 atmosphere. So I'm going to convert to 1 atmosphere of pressure, so the absorbed pressure. Calculate the mass. Oh, so this one's a little different. Of the air in the room. Air is mostly nitrogen, so let's pretend that this is all nitrogen. Nitrogen is N2. So the way we would do this is we would use our P, our ideal gas law, P times V equals nRT, and we would solve for N. Okay, so then what we would do is we'd solve for N, and then since we know the molar mass, we would kind of manipulate it then. So now let's plug in our numbers. So my pressure is 1 atmospheres. My volume is 8,500 liters. And again, remember our units are important. N is my unknown. My R is 0.0821 liters per atmosphere divided by moles Kelvin. But I'm not gonna put all that. And then my temperature I need to convert. So my temperature is in degrees Celsius, but I have to convert it to Kelvin. So I add 273 to my 25, and that equals 298. So I would solve here for moles for N, and I would do that by isolating it, so divide both sides by the other two variables. So I get my N value would be 347.4 moles. So now you may think, well, how am I going to get the mass? So remember that the moles of something is equal to the mass. So the way you would find how many moles is you would have mass divided by the molar mass, and that would give you how many moles you had. So if you already have the number of moles and you want to find the mass, you would just multiply now by the molar mass. So my moles in this case, let me move to this side over here. My moles in this case would be 374, so, or 347.4. That's how many moles I have of N2. My mass is my X value. I don't know what my mass is, how much that is. And then my molar mass would be nitrogen times 2, so N2 would be 2 times nitrogen's mass, which is 2 times 14 basically. So that's 28 grams. So 28 grams, that's the mass of the molar mass of nitrogen. So I would just solve for my mass. So this 347 times 28 gives me a total mass. So my mass for this would be 9,727.8 grams. So that's kind of a lot. And that's how you would do this type of problem. Here I want you to determine the density of methane at STP. STP is something that you guys have to familiarize. This is standard temperature and pressure. So the standard temperature and pressure is going to be 1 atmosphere and 0 degrees Celsius. Okay, so that's STP. Sometimes, depending, I believe on your little chart thing, yes, they give you also the STP there. Okay, they give you what it is. They put 0 degrees Celsius, but also 273 Kelvin. So we want to know the density. Density is basically grams per liter or milliliter, but grams per liter works. And we can get this by using our ideal gas law formula. So my pressure would be 1. My volume, I'm not sure. My moles, not sure again. And then my what's it called? My R is a 0.081 or 21. And then my temperature, this is 0 degrees Celsius, but we could convert it to Kelvin by just adding 273. So my temperature is, in this case, 273 Kelvin. So what I would want to solve for is N over V. So the moles over liters, because then I can figure out my density by just using my molar mass. So then what I would do is I would divide this side by V, and then divide this side by 0.0821 times 273. So I would have 1 over 0.0821 times 273 is equal to N over V. And I end up, my N over V ends up being 0.0446. Now, this gives me moles over volume, which is not density. Density is grams over volume, but I can use my molar mass like I did up here. Okay, so let me just do that. Remember, moles is, so right now what I have is I have moles over liters. What I want to convert to is grams over liters. So this is CH4. Carbon's mass is 12, and hydrogen, there's 4 of them, would be 4 times 1. So in total it would be 16. So the molar mass of CH4 is 16. And that means that 16 grams per mole. So what I would do is I would take this and then I would use my conversion. So I would multiply it by the 16 grams for 1 mole. And that would cancel my moles and it'd be grams over liters. So I would take that point and multiply by 16, the 0.0446. And now my density ends up being 0.71 grams per liter. And I can leave it like that. Okay. So this would be, this problem right here would be about the same thing, except now we have new temperatures. So we use the almost exact same formula, the same process, but now we would have different numbers for my temperature so the temperature would be different and then the pressure would be different. And again, to get, for this one, if I wanted to get my pressure, I would just, in the atmospheres, I would just divide by 760. So I'd get 0.98. Okay, so now if I wanted to do this one, here I'd have to convert, so 223 plus 273 would give me 296. And then this 745 divided by 760 gives me 0.98 atmospheres. So again, I would use my same formula. I would have N over V is equal to P over N times, oh no, not N, I'm sorry, R times T. Okay. And then what I would do is I would just plug in my information. So I have my moles over volume is equal to my pressure, which is 0.98 over 0.0821, that's my R, and then my temperature is 296. So I would do the calculation. And I would get my N over V would be 0.0403. And that's moles, because remember N is moles, and then volume would be liters. So then next, all I would have to do, I'm in the same place as I was here, is multiply, because we still have CH4, multiply it by our molar mass. And I would get 0.645 grams per liter. So my pressure went down and my temperature went up. And if you remember, when your pressure goes down, well, actually the density is a little bit different, so we won't talk about that right now. But so that's what we get. Okay, and then now this last one is we have 12.5 grams of gas that occupies 10.5 liters at 20. So here we have a volume, here we have temperature, we have our pressure. Again, we need to convert these two. And then here, instead of moles, they give us mass. So they give us a mass. And remember, for moles is considered the mass over molar mass. That's how we get it. Okay, so it would be, in this case, grams per mole. So what we would have to do is solve for N. In this case, we need to know what N would be. And then we would take our mass and divide it by the moles to find our molar mass. It's kind of like switching. These would switch. So then we would do that. First we have to convert our temperature. So 25 degrees Celsius plus 273 gives us 298 Kelvin. And then for my pressure, I would have 755 divided by 760, because 760 millimeters of mercury equals 1 atmosphere. Gives me, I'm sorry, 0.99